Corporate Finance Core, Topic 3, DCF, Debt, and VBA, Learning Objective number 3. We're going to compute loan cash flows and effective rates. So let's think about three types of loans. Discount loans, interest-only loans, and the most common, amortizing loans. So a discount loan is the simplest type of a loan. So you receive a single lump sum today, and you pay back a single lump sum in the future. So say you borrow $9,345.79 today and repay $10,000 in 1 year. You can compute the effective interest rate by taking my future value minus my present value divided by my present value, and that rate of return is 7%. So that is effectively a 7% loan of $93.45. Now another type of loan is an interest-only loan. What if you borrow $10,000 today and repay 5% interest per year for n years, and then repay the principal at the final payment? So what that would mean is 5% of $10,000 is $500. So I'd get $10,000 today. Then I'd pay $500 or $500 per year, and then when this loan matures, I would pay that $500 plus the $10,000 back. In other words, all the principal is repaid at the end. But what if you have the most common type of loan, like we use for car loans and home loans? They're amortizing loan. In other words, you don't pay back your principal at the end, you pay back your principal in every payment, and every payment includes both principal and interest components. So what if I borrow $40,000 for 5 years? It's a level payment loan, an amortizing loan, has an annual percentage rate of 5%, we call that the APR. Now each payment is going to contain both interest and principal, and you're going to pay off the loan exactly over 5 years. So Excel's payment function, the PMT, will compute that one payment that'll be paid off over 5 years. And so here are the inputs. We're going to make that $100,000, 5 years, the 12 payments per year, it's monthly payments, and an annual percentage rate of 6%. I'm going to set up my payment function. Since this is monthly payments, I'm going to have 60 payments, which is 5 times 12. The present value, I put a minus $100,000 there because I want the number to turn out to be positive. And where it says interest rate, since I have 60 months, I need to make sure this is the monthly interest rate. So I put in the 6% divided by 12. It's a 0.5% per month. And that number turns out to be $19.33. So I'm going to pay $19.33 a month for 60 months, and my loan will be paid off. And I just want to prove that. At the first period, you owe $100,000. In that first monthly payment of $19.33, you owe the 6%, I'm going to anchor that, divided by 12, that's that 0.5%, times my beginning balance, $100,000. So my first interest payment is going to be $500. However, I paid a total of $19.33. I'm going to anchor that. So minus my $500, I'm paying off principal of $14.33 in the first payment. So if I wanted to pay off my loan, fully pay off my loan at the end of the first month, I owe $100,000 minus $14.33. Now my beginning balance for month 2 is $98. If I copy these formulas down, the interest component is going to fall because I'm paying a 0.5% of $98,000, which means my principal component is going to rise. Now I'm going to copy this down to the 60th month. Notice I have a little trick here. I've hid a bunch of cells. If you highlight between 12 and 62, right click unhide, you can see all the payments, but I'm going to right click hide. And what you see is just by the magic of the formula for the payment function, the last payment in the last month, the 60th month, I owe $19.23. I take a 0.5% of $19.23, it's $9.62. The $19.33 minus the interest component is exactly $19.23, and I'm exactly paid off. That's how you know you did the right calculations in this. So In this problem, we borrowed $100,000 for 5 years, making monthly payments of an APR, annual percentage rate of 6%. Let's talk about APR and EAR. What if I have a choice between an annual interest loan or a monthly payment loan? So we can convert loans in which payments happen more than, say, once a year to an annual for comparative purposes. So our formula is going to be the computation of the effective annual rate. We'll talk what that means later after we do the calculation. Is 1 plus the APR, that's the number we just used in the last example, that's 6% per year that we did for 12 months, raised to the 12th power in that example. F is the frequency, the number of payments per period, minus 1. So if I just plug in my equation here, if I took that 6% loan that paid 12 payments per year, I'm going to divide 6% by 12 and take it to the 12th power, minus 1, 6.1678. So effectively, by paying 6% per year but making the payments monthly, it's like paying a single payment of a single loan payment of 6.167% interest. So I'd be indifferent between a monthly 6% loan and an annual 1.1678% annual payment loan.